Hi, Holly. Welcome back.
Thank you.
And today is about class loading and dev services. And Quarkus, of course, right?
Yes. There was a pause there as I sort of, was like shaking in my boots slightly.
Okay. Regarding class loading, maybe we should start with classic application server class loading and then contrast that to Quarkus, right? Because it's vastly different. As I remember, I try to recall it. So if we have a classic application server, let's take OpenLiberty because I think you know OpenLiberty for sure. I know more GlassFish, but should be similar. So there's a hierarchy of class loaders, right? So the first one is the Java's class loader, is the system class loader, which loads Java lang string, for instance. And then we got an EA class loader, as I remember, right? This was the biggest is enterprise application class loader, which could load some libraries like this was rare, but you could actually have libraries on EA level. And then the war class loader and EGB jar class loaders inherited from the EA class loader. And so they saw whatever EA saw plus additional stuff, right? Is it roughly correct?
Yeah. So with Liberty, it's going to be a little bit different because.
Okay, then go with Liberty so that we see.
Yeah. So I want to speak carefully because it was a long time ago that I last worked on Liberty.
Mm-hmm.
But I think one of the things that Liberty really changed compared to traditional WebSphere was the class loading model.
Okay.
So I think
or maybe you could start with the classic WebSphere, then Liberty, and then Quarkus.
Yeah, and see, this is going even further back, and so I'm pretty hazy on the classic WebSphere class loading model because I don't think I ever knew it particularly well, and if I did, it was a long time ago. But I think it's certainly reasonable to assume it's similar to what you described for GlassFish. So the sort of the goals is that you have isolation between the first goal is that you have multitenancy and that you have isolation between your applications. And in order to do that, you have to have the different class loaders, but then you have a common layer of application classes. And one of the problems that Liberty was trying to solve was the fact that you would get bleed through from internal classes of the application class loader, internal classes of the application server into the application. And the classic one that we always had problems with was SLF for J. So there would be sort of 16 copies of the logging framework somewhere on, in all of the various jars. And there was a risk that you would get the one that was used internally by the application server instead of the one that your application used. And sometimes with some classes, it doesn't really matter too much which one you're using. But with some libraries, there really either there's behavior differences between the versions, which matter a lot, or with something like Antler, there's these really strong incompatibilities where if there's an Antler 3 somewhere on your class path, Antler 4 will say, well, no, I'm just going to refuse to work because I can see that there's some Antler 3 somewhere and the behavior is going to be non-deterministic. And so in order to avoid any problems, I'm just going to shut down. So it was sort of it was a perpetual source of problems with classic WebSphere was that the internals of WebSphere would be using some of these classes that applications might also use, and then there'd be conflicts. And so one of the sort of the innovations of Liberty was to go to this OSGI model of class loading, where you still had the isolation between applications, which you'd had with classic WebSphere, but you also had a distinction between internals and externals. And so Liberty could say, well, we use these classes internally, like our logging framework, but we don't expose them. And so if they don't end up in the OSGI manifest, they're not exposed. And so it allowed this really tight control over what got leaked out to the application. And it also solved another problem, which wasn't necessarily obvious to application writers, but it caused us a bunch of problems internally, which is that the WebSphere was a big product and it had a lot of teams working on it in a sort of, distributed model where we had, a site in Austin and a site in Poughkeepsie and a site in Hursley. And what would end up happening was that you would need some capability, and you would find somewhere on the web, in the WebSphere source code repository, you'd find a class that did exactly what you needed, and you'd be like, oh, great. So you'd start using that class for your internal stuff. And it was an internal class, and we're all internal, so this is all okay, until the person who owns that class, who is, on a different continent to you, changes their class because they didn't know anybody was using it. And then all of a sudden, things break. And so we with classic WebSphere, we'd really struggled to maintain internal application boundaries as well. So we struggled to maintain that modularity, and OSGI just gave us that. So it meant that even within the sort of the internal modules of the server, we could control what got exposed to outside users, but we could also control what got exposed to our colleagues, because as soon as you expose something, you lose the ability to change it.
Yeah.
And then you're sort of frozen, and you just build up more and more kind of technical debt of stuff that you want to change that you can't. So you have to support both models, and it just ends up being really expensive, and eventually sort of things collapse under their own weight unless you have the ability to change. And the only way you can have the ability to change is encapsulation.
What I forgot to mention is the bootstrap class loader is from JDK, then the system class loader. And what I described was the classic class loader hierarchy, but I look up BA and GlassFish, and this was actually different. So interestingly, there was a bootstrap system class loader, then which is a common application class loader. Then we got EJB class loader, and from EJB class loader, war class loader or web class loader inherited. And but what I remember, I was in some task forces in a project where we got an error, like, what was it? I think ClassCastException, customer is not customer. And what happened is there was a web archive, a long time ago, web archive and EJB jar, and both had the same class loaded, but there were two class loaders. So, and if you have the same class, so class is defined by the type and by the class loader it's loaded. And in this particular case, it was loaded by two different class loaders. So we saw actually a Java error, which is interesting. It's like, customer is not a customer with exactly the same type. And I forgot which application server it was, maybe JBoss, I don't know. But I know that GlassFish make this configurable, like delegate yes or no. And then BA, I look it up, they changed the hierarchy so that when the war inherits from EJB jar, then you don't have the problem because the class is already loaded, so it won't be loaded again. So what you get, we have interesting problems. We don't want to be too isolated because otherwise, if you have two jars, they cannot refer to each other. They cannot share any classes. Or you will have to move classes out to the common class loader, which would make sense, but lots of the projects didn't do that. And what you described goes a step further. So first, if we solve the class loader problems, then we need isolation. And this is where I think OSGI kicks in, where you can specify, only expose classes from this folder, which another reason why I didn't like OSGI a lot in business projects, because OSGI forced to introduce additional packages. So what you usually had is like impl and API, and everything which was in API was exposed and impl was hidden. And API is fine, but I didn't like the name impl, so it should be whatever it happens there, not just impl. Because in business projects with lots of external consultants, if someone saw impl, util, common, or whatever, there was impl and common for everywhere. So there was over with proper naming. So this was the only criticism. Of course, if we are product development, small focus team, complete different story. Mm-hmm.
Yeah, that error of something cannot be cast to something when they're the same thing is horribly familiar to me, because I did a big rewrite of the Quarkus test class loading architecture. And hopefully there's none of that now, but, in the sort of the period when, all of the code was kind of lying on the floor with its, guts falling out, I just kept getting that exception.
Were you surprised the first time, or you knew what was going?
Yes, I'd completely forgotten, and I was staring at my screen going, is there a typo?
Yeah.
And, now when you say it, I'm like, oh, yes, of course, it's obvious. But yeah, the first time I got it, I was just like...
And there are two similar errors, like classcast and no class def found error, I think, right? And they are very similar. I forgot what is the reason of no class def found. There is a subtle difference when classcast happens and no class def found error happens.
Yeah, and because there's three. So there's no class def found error and class not found exception. And one is because we were just talking about this the other day. So the class cast is if there's two classes that should be the same or should be convertible, and they're not. But the no class def found, or the class not found exception, is a user problem. So that's something like you tried to load a class and it just wasn't on the class path, so it's not going to work. The class def not found error is an internal one where the JVM is fairly sure that it should be able to find that class because it was there last time it looked, or something like that. But then it goes to load it and like the file system has changed, or it wasn't where it left it, and so it gets quite upset. But it's not something. It's an error because it's not something that the user can recover from.
The last line in the Java doc of no class def found error is the search for class definition existed when the currently executing class was compiled, but the definition can no longer be found.
Yeah, yes, exactly that. It wasn't where I left it.
And this happens if you compile something and then the class loader cannot find it, right? This is exactly that. So you compiled, everything is fine, and then you are searching with class for name new instance, and then it cannot be found. I think this is when it happens. Genau.
Or if you write your own custom, if you write your own custom class loader, then
Genau was German. So exactly. And the no class def found error, the class not found exception is the normal one. This is when you try to do something which is not there. And no class def found error, if you see this, usually means you're a little bit in trouble. So it compiled, but you're doing some magic with class loader and it doesn't work, right?
Yeah, and so usually you might see that if you're like writing your own class loader and you've done something stupid. I want to go back to something you mentioned though about when with the isolation, when you should delegate to another class loader, because this is a decision that every application server has to make, and it's something that tends to be different in application server architectures compared to other architectures, which is every server has to make architectural decisions about whether to load classes parent first or parent last. And normally, in a normal Java application, the architecture is that you would load things parent first. And so the idea is if you want to load something like Java lang string, that should always be loaded by the system class loader. You shouldn't have your own copy of it, because if I have my own copy of it and you have your own copy of it, then that means that we can't communicate, we can't pass it back and forth. So you want to have the common source. So you always want to be loading these things parent first. And then if the parent can't find it, because I've loaded my weird custom class, then the system class loader or whatever the parent class loader is should go to me and say, hey, I can't find my weird custom class. Have you got my weird custom class? And I say, yes, I have. But in a lot of application servers, because they have this strong isolation model, and for various other reasons, they will often load parent last instead. So the classes that you load will be loaded by the isolated class loader at the sort of it depends which way you draw it, whether it's at the top or the bottom of the tree, but it's the one that isn't the system class loader. But of course, for some classes, that doesn't work. And so then what we do in Quarkus, and I'm fairly sure we did it also in Liberty and also in classic WebSphere, just with slightly different mechanisms, is you have these exception lists. So you say, even though most Java applications would do parent first class loading, we're going to do parent last class loading in order to achieve this isolation, because the isolation is a feature, not a defect. But in some cases, isolation would be a catastrophic defect. And so for these classes, we're going to load them parent first instead.
And this is why the application server starters, to repackage the external libraries, not to have conflicts, right? So what applications, because the problem is, let's say application server is also built in Java. That's a problem. And if your application server is built in Java, then it can use, let's say, SL4J or Log4j, something which is not in Java. And then the class loader already loaded a library. And now I have a problem because maybe, per accident, I would like to have the same library with a newer version.
Yeah.
And because the library is already loaded and you said parent first would mean the application server has the class already loaded. So I don't get the class from my library. I will get this from the application server. And this could surprise me because it is supposed to be hidden what the application server is actually doing or using, right? Because it's the platform which shouldn't affect me. And exactly. And parent last wouldn't work in this particular case, I think, because the application server needs the class and it will load the class anyway because the application server starts before the war is loaded, right? So this is the problem. This is why the application server starts to repackage. There is not like what is Java, what is Log4j org Log4j, I guess, dot something. There will be like com IBM Open Liberty dot. They just repackaged so that the package name is different, then you don't get the collisions, right?
Yeah. Yeah, and we had it's sort of, it can be quite delicate. So in Quarkus, if you have some library and it just isn't working with Quarkus and there's no extension available, then one of the sort of the knobs that you have is you can change it so that the classes are loaded parent first. So like it used to be, we fixed it, but it used to be, for example, that if you wanted to use packed with Quarkus, you would need to set some of the packed classes to load parent first. But then what often sometimes happens is it's like viral as well. So any class that loads parent first, the classes it loads sometimes then need to load parent first. And so then you start off, with just one package making it load parent first. And then before you know it, you've got like 15 packages that all have to load parent first and your application still doesn't work.
Mm-hmm. It's always viral, I think, right? Because if the first class is loaded and this other needed, then all the classes referenced by this first class has to be loaded.
Yeah.
Mm-hmm. Okay, so we talk a little bit about application servers and this parent first and parent last. This is what I remember, and also the setting delegate yes or no, and I tried to avoid this by not having too many dependencies, and it worked actually quite well. So in my project, we never had problems with class loading. Now, how Quarkus is different? So it means the Quarkus class loading hierarchy has to be different because Quarkus and the application is one thing. So Quarkus builds the application and you ship one thing. And the application servers were different because the application server was started first. So there should be already some class loaders in place. And then the applications were deployed on demand, which means they were started on demand. So so for every app, there was a class loader, and this was then the idea, right? And redeployment, you hoped that the class loader was garbage collected and everything is gone, a new class loader was started. This is my understanding how this hot deployment worked on most of application servers, right?
Yeah, and so with Quarkus, there's different design goals with Quarkus, and so then that means that you have the different class loading architecture. But with Quarkus as well, there's 3 different modes of running, and they all have different class loading architectures. So you could run in production mode, and you could run as a natively compiled binary, or you could run in dev mode. And so I'll talk about production mode first. So with production mode, Quarkus doesn't have a goal of allowing you to have multi-tenancy. So with the old application servers, the model sort of tended to be that you would have everything in the kitchen sink in your platform. And then you would have, because your platform was quite heavy, you wanted to share your platform as a resource between multiple applications. With Quarkus, instead, it will have a bit more of a tree shaking model, which says, let's just get your set of dependencies so small that we don't need to support multi-tenancy. And if we're not supporting multi-tenancy, there's a whole bunch of complexity that goes away. So you're actually saving by not having the multi-tenancy rather than losing by not, consuming more resources by not having the multi-tenancy. And so as soon as you don't have multi-tenancy, you don't need the class loader isolation.
And multi-tenancy, you mean one platform and multiple applications inside, right?
Exactly, yeah. So, we don't need to have the application from my team and the application from someone else's team sharing an application server. And so as soon as you don't have multi-tenancy, you do all of that need for the isolation and the EAR class loader and the WAR class loader and all of that goes away because there's only one application. And so what that means is that Quarkus can have a completely flat class path. So then the next question is, if Quarkus has a completely flat class path, class loader hierarchy. And so if it's completely flat, does that mean it's the system class loader? And the answer here is interesting because we're just in the process of thinking about changing it. Historically, Quarkus hasn't used the system class loader because the system class loader was slow. And so we had...
Why it's slow?
There's some optimizations that it could make for the for the loading process that it doesn't, which is fair enough, right? Because it's very generalized. With Quarkus, because we do a whole bunch of work at build time, we can do some work in order to make startup. We do all sorts of work to make startup faster. And one of the things that we do is try and speed up class loading. So we pre-index classes. So normally when the system class loader will start up, it will have to do some indexing. We do that in advance. So we have a special runner class loader.
It's the Jandex, right?
Sort of. I think this is a different index. So I think Jandex feeds into it, but I think the actual... I'm not 100% sure, but Jandex is so we sort of talk about Jandex as like reflection, offline reflection and supporting off that. And so I think for the fast jar format, the index probably isn't the Jandex index. I think it's a more specific index to just say, here's what classes you have available. Here's the metadata about the classes that you would need to discover on startup. But I'm not 100% sure about that. But the idea is that, so we have this fast jar format. And so if you which is, has the extra indexing information. If you combine the fast jar with the runner class loader, you get faster startup. But it gets more complex with Leyden. So the idea of Leyden is to speed up the JVM startup by doing extra stuff at build time. But it's a JVM level thing, not a Quarkus level thing. And so what we're discovering is that Quarkus is a really nice fit for Leyden. So we can do things like, normally with Leyden, you'd have to do a training run, and just running the Quarkus integration tests will count as a training run. So we get the information just from running the tests that you need in order to have that fast AOT startup. But for the moment, Leyden will only work if you're using the standard JVM class loaders. And so what that means is that we did some experiments, and we found that if you start Quarkus with the fast jar, it would take, 400 milliseconds. Because it's not really, with the fast jar, it's not able to hook into some of those Leyden optimizations.
And fast jar is the specific jar meant to be for the optimized class loader. So the fast jar contains the index, which is so we clarified what fast jar is.
Yeah. Okay. And we have another format, which is called legacy jar, which is just your normal jar. And so if you start Quarkus with a legacy jar, we won't use the Quarkus class loader. We'll just use the standard system class loader.
How much slower is it?
Oh, that's a good question. I don't know.
So we will have to do, some experiments, because it would be cool to see 400 milliseconds versus what will be mean is if we have a standard Java app with main and started, then we start in 300 milliseconds, and with the Quarkus fast jar, it will be even faster.
Yeah, so I think it's sort of order of magnitude, like this is just a wild guess, but it's sort of, I think with normal JVM, the legacy jar is sort of order of magnitude of like 50% slower, twice as slow, something like that. So it's not like 10 times slower.
Okay.
And it's just a startup time thing. But what we're finding is if you enable AOT so that you can take advantage of the new Java 26 Leyden AOT, the legacy jar is now much faster than the slow jar because the AOT in Leyden is really powerful. And so we now have we're working on or thinking of a new jar format, which is basically the legacy jar format, but we're going to call it the AOT jar because it will allow you to take advantage of AOT, and we had this sort of slightly ridiculous situation where the fast jar was slower than the other jar with AOT. So we're sort of that's kind of being worked on at the moment, and we're finding with the new AOT jar, we're getting and Leyden, we're getting really fast startup times now. So they're on some of my colleagues' machines now, they're seeing 100 millisecond startup, which is insane, really pretty cool.
What also means is not the end of the story, because you are forced to use the legacy format. But if Leyden would expose some hooks, we could actually use the hooks to index the classes in Leyden and use by Quarkus fast jar again, right?
Yeah, exactly. And that's, I think, we're definitely hoping that that's what's going to happen. And we're asking the JVM team for those hooks, because it would be so nice because at the moment we kind of have to choose like the optimizations that we get with fast jar or the Leyden optimizations. And at the moment the Leyden optimizations are better. But like if we could have both sets of optimizations, that would be the best of all worlds.
So it could be below 100 milliseconds, absolutely possible.
Yeah. I mean, I think they're sort of pretty much there now, at least anecdotally, and and then it could sort of get even better.
So what means is that GlassFish, Quarkus right now has one class loader, basically, right? In production.
In production, yeah. There's possibly one or two more. Like there might be, another one that's like a bit doing bootstrap and that kind of thing. One of the things I hadn't really thought about it, but my colleague David Lloyd pointed it out, is that class loaders tend to proliferate. They're one of those things that if you have a team of people working on something, or even if you have one person working on it and they work, over a period of time, they're one of those things that people tend to just create class loaders to solve problems. And then you blink and then you've got like 8 class loaders. So if you look at the Quarkus code base, there's like a lot of class loaders, some of which are, so the main thing is, we have this flat class loader, but there's various other little class loaders that have, snuck in for one or two things. So I think at some point we're probably going to do a class loader clear out and class loader rationalization, because, that it's just a thing that happens to teams is you end up with class loaders.
Means Conway's law also happens with class loaders, right? It doesn't only apply to microservices. It started with class loaders first and then microservices.
Yeah, exactly.
So because what Conway's law says is that the architecture reflects the organization, company organization structure, basically. And I can see this because class loaders come with isolations. The same is true for microservices. This is like a process isolation.
Yeah, and you can do so much with a class loader, and you can solve so many problems with a class loader. And so it's really natural that if you have a problem and you know how to write a class loader, you write a class loader.
For fun, I created a short last year or way ago where I implemented a base 64 class loader. So I could encode a class in a base64 string and then load it. And it worked. Just to, this was like, I don't know, 4-line or whatever, just to explain what a class loader is. But the comment was funny. Someone told me he would never use it in production. It's like, no. This was just because he said he wouldn't use it in production because there couldn't be trouble in CI/CD. I say, yeah, this was just fun. And what I did a while ago, I implemented a framework, and the idea was to persist all the classes with the state in a class loader. So I used serialization back then, which was probably very slow. It was very slow, but it worked. So I can move around. It's almost like an agent. But this was like in 2000s, was just for fun. It's not a lot to do, but it was fun exercise to implement such a thing, because what ClassLoader does, I also remember there are like two classes and two methods, and one asks, are you loaded? And if you're loaded, give me the class, and you can actually extend from it, and you can load classes from wherever you like. Oh, this was a network class loader. So what I had something like an applet, I could load remotely from a web server all the classes. And of course, I wanted to have a cache, and then I persisted the cache. So I could have something like a Java Web Start. I implemented Java Web Start before Web Start, and it worked actually well. So it was a nice little project. So
you could do images and load. You could include classes into images and just.
This is what I did. Versions, and I could say, okay, now forget all the cache, and then it was like it updated everything from the server. So this was back then. Yeah.
Yeah, or I was thinking images like PNGs.
Oh yeah.
Yes, or GIFs or.
Yeah, this would also work, right? But it was like a binary image of all the classes. This what worked well, and so what I assume that the Quarkus in dev mode class loading is way more complicated.
It is, yeah. For two reasons. So if you look at the sort of the chart of the class loading in dev mode, there's about 6 class loaders in there, 5 or 6 class loaders. And the sort of the natural question is, but why are there so many? And there's two problems that are being solved. The first is that when you build a normal Quarkus application, what will happen is that at build time, you'll have access to this really rich set of classes, and they will do things like reflection in advance. And so your CDI injection will be sort of pre-resolved. And so there's a whole bunch of library logic that you need at build time that you don't need at runtime because the work has already been done. And so then that means that the runtime class path is really lean, which is great. So if you're in dev mode, we still need to keep, and so one of the things that that as an extension author you have to be really strict with, and as a runtime as a runtime, you get this thing where at runtime, anything that you had at deployment that wasn't marked as available at runtime is not visible because it it just didn't make it into the binary, it didn't make it into the class path. But if you're in dev mode, they're all sort of mashed together and available because you haven't been turned into a little jar and shipped off through a CI/CD system. And so we need to make sure that you don't end up in a situation in dev mode where, because you can see these classes that are build time classes, we call it deployment, which was in hindsight a truly terrible name. And so it really should be called something like build, but build is used for all sorts of things. So we called it deployment. But what it is these compile time classes. But we need to make sure that when your application is running, it doesn't have any visibility of the compile time classes so that you can see, is this working? Will this work in production? So you have to have that isolation. So we have sort of two pillars of class loading. One is those compile time classes, and one is the runtime classes. And in terms of what's actually happening, we access both of them, but we keep them isolated. And then the other sort of thing that we're trying to do is we're trying to support the hot reload, that live reloading. And so what that means is then you need to have an architecture sort of similar to what you were describing for some of the older application servers, which is that you have a class loader and it will have access to some it will have loaded some classes. If those classes change, we need to throw that class loader away and get a new one that has the new classes. But we don't want to throw everything away. We just want to throw away the minimal set. So we'll have a hierarchy. So we'll have what we'll call like a base class loader, which is the classes that we don't want to throw away. And then we'll have an overlay class loader, which is the actual runtime class loader. And if we decide we need to reload classes, we'll throw that class loader away and make a new one with the new classes. But it's because it's just one tiny little class loader and everything else stays the same, it's a pretty quick process.
Which is what means is that Quarkus in dev mode is very similar to application servers in production mode.
Yes.
This is interesting. The same patterns you can actually borrow from old application servers to make Quarkus work in dev mode, because you have the same problems. And you could even, it doesn't make any sense, but it could work. You could maintain, you could introduce multitenancy.
Yeah. Yeah. So you've sort of got like multi-tenancy, but in time rather than space. So instead of, like my application and my neighbor's application, I have my application and future me's application. And they need to, well, not coexist, but they need to coexist in time.
And you have to be really careful, because what can happen is that an application in dev mode doesn't work, but in production mode does, and vice versa, right? So it has to, you have to use the class loaders to simulate the production behavior, actually.
Yeah, it's a funny thing where in order to simulate the behavior of a flat class loader, we need like 6 class loaders. But it seems to work really well. Like there's a category of defects of like, I tried this in dev mode and it worked, and it didn't work in production mode. And I don't think we really see any of those defects. There's another category of defects, which is I wanted to do this really complex thing with this complex library that does a lot of class loader manipulation itself. And my tests work if I run them just with Maven Verify, but if I run my tests with continuous testing, they don't work. We do get some of those defects because making the tests behave correctly when there's, lots of things fighting to control the class loader hierarchy and the class loader behavior is complex. But even those defects, we don't get too many of them.
What I'm thinking about is actually you will have to do really fancy stuff in order to break this, right? So you will try to introduce your class loaders, or try to overlay Quarkus classes with your classes or something like this. So in regular application, this is almost impossible that you encounter such problems, right? So you know what the applications did? That or what was because for me it would be really hard to break this principle, right?
Yeah, usually it's with bytecode manipulation.
Okay.
So some test libraries, for example, really like doing bytecode manipulation. And then it's about which class loader is visible at the right time.
Yeah.
And so this was kind of what prompted the class loading rewrite. Actually, is the way we used to do the class loading was JUnit has the test class loading was that JUnit has a whole bunch of hooks that allow you to swap out the class at runtime, like at execution time. So JUnit will look at the class path, it will discover the classes, and then you can say, oh, but before you actually execute this class, can you please call my hook? And so in that hook, we would say, so rather than the class that you loaded off the file system, which doesn't have any of the Quarkus, reflection in advance adjustments, why don't you take this copy of the class instead? And that worked mostly well. Well, I mean, it worked really well, but it ended up being fairly complex because it's a bit like what you were talking about earlier with the sort of the viral class loading, that we wouldn't just have to change the test class that we cared about. Any classes that were parameters, we would have to make sure that those parameters were also loaded with the right class loader. And so that means that the actual instances of those parameters, we would have to recreate with the correct class loader. And that's becoming harder and harder to do. So before Java 17, you could just do it with reflection. And there was libraries, I think it was Xforge. There was various libraries that were for solving exactly that problem. But ever since Java 17, the JVM has been locking down what you can do. And one of the things that it's really fairly unhappy with you doing now is cloning application or cloning classes from one class loader to another, because it means you have to access all of the internals of that class. And they tend to be sealed off. So we were finding that it was harder and harder on the newer versions of the JVM to make that pattern work, if as soon as we ended up in a situation where one of the parameters would have been loaded in a non-system class loader. And we also had problems because if you had a testing library that would do bytecode manipulation, so Pact was one of those that would do bytecode manipulation, and there's various others, you'd end up in a situation where it would do the bytecode manipulation, but then the Quarkus framework would load in the adjusted class, but it would be too late. And the JUnit framework would have already seen the unadjusted class, and so then you'd just end up with, again, sort of, fields that were supposed to be injected hadn't been injected, or...
You could even have race condition with class loaders, right? This is a hard problem to solve. I mean, you can have a Heisenberg that is, sometimes it happens, sometimes it doesn't, right?
Yeah.
Depending on your hard disk speed even.
Yeah, yeah. And so what we
Do you have many sleepless nights with class loaders?
Oh, it is. Class loading is a real headache.
You like it still, or
no? I don't think I ever liked it, to be honest. It's not. I say it's not what I would have chosen to do, but actually, of course, I did literally.
I'm just waiting for the class loader visualizer.
Yes, I know. I really want to do that
in 3D AR experience. Then you can move, multi-dimensional, so you can move forward to see one class loader in different versions and sidewards, between parent class loader. So this is where we'll meet next time in AR glasses.
Yeah, it would be so cool if because you could have it sort of watch it while your application's running, and you could see the class loader light up when classes are coming from it and stuff.
Yeah,
so, that will be a weekend project someday.
And class loaders in dev services, I think, are also needed, because what could happen is that I decide to implement a extension which, let's say, measures the performance of the application only running in dev mode. And this will require to have additional classes which are not available in production, right? This is a very common thing to have. So my extension, I could have an extension which, for instance, profiles Quarkus, but this only loads the profiling stuff only during dev mode and not in production, right? This is possible.
It is, yeah.
And this is why you need the various class loaders for various types. So it's okay, this class loader, not the entire branch of the dev, how to call it, extension, dev service or whatever, is not available in production, for instance. Mm-hmm.
Yeah, so we've got, we used to only, if you wrote an extension, there used to only be two modules. So there'd be a runtime module and a deployment module, where the deployment module, confusingly, was the non-deployment module.
It was not built in runtime?
It wasn't build, because the problem is, if you make a folder called build in a Java project, loads of tooling will look at it and go, that's where your output goes. I'll just delete that for you. Or I'll, treat that as ephemeral or whatever. So we couldn't really call it build, so we called it deployment.
Okay.
But deployment did imply that it was the thing that would go out and get deployed, when it was actually the thing that exactly didn't go out and get deployed. It was the compile time support. But leaving that aside, so we had deployment and we had runtime, and now we have a module called runtime dev as well, which is mostly used for the dev UI, but it allows you to have exactly that. I want this to be available at runtime, but it really shouldn't go out into production, because these are classes that are only useful in dev mode.
Okay. I thought it was always the case, but it was recently introduced?
It was recently introduced, yeah.
Okay. And what I remember is that at the beginning, the Quarkus in dev mode, there was, I think, the same behavior as in production. So Quarkus was as fast that it could reload everything just by reloading everything. There was no optimization in place, right? Wasn't the case in the first releases of Quarkus that the dev mode was just, restarting Quarkus behind the scenes?
Yeah. And we still do have to do that depending what you change. So there's sort of a 3 tiers. So some things, when you change them, we have to restart the whole application server. But the good news is that usually you don't notice because it takes, like a second or so. So by the time you're sort of noticing it,
it would be cool to have a switch to say, hey, Quarkus, I don't trust you. Just restart yourself every time.
I mean,
you know what I mean? That is,
I do, yeah. But I think it's pretty
stable.
Yeah, I think that's another category of bugs that we don't get because we do sort of err on the side of, if we're not sure if we need to restart, we do the restart because we can afford to. So things like application properties or resource files, some of those you wouldn't trigger a whole restart. We would just restart the affected thing. Actually, I'm not sure whether application properties, that was a bad example. I'm not sure if application properties triggers a whole restart, but certainly there's some resource files. Like if you've got a web application, some of your resource files, we just reload the affected file. And then there's like a middle tier where we need to reload the class, but we don't need to bounce the whole framework. And then there's the sort of the most significant tier where we need to restart the whole framework. But in general, yeah, I think we get it right, and if we get it wrong, we are on the side of restarting too much. So it's not a category of bugs.
But it was at the beginning really fast. So I've worked with Quarkus, and I look at the Quarkus, and this is crazy, because what I liked, no magic and still fast. It reloaded everything, and it was faster than hot deployment of application servers. So at the beginning, it was one of my what I sold as an Quarkus advantage, that there is less magic and it's still fast. But you're right. If you do more, you have to optimize, because if the application gets bigger and bigger, maybe it will take seconds, to restart everything, and then it's just too slow.
Yeah, and it's something that we keep pushing on as well, because I think there is a natural tendency with everything, to just sort of, you get this kind of 1,000 paper cuts performance degradation, and it gets slower. So we really sort of try and be pretty vigilant of, like, every few months, one of us will sort of go, you know what, today I'm going to, I think in 3.3.1 or 3.3.2, in one of those releases, Guillaume, he really attacked the compile time for large applications. So he was like, and he just sort of went at it, and he went at it with the profiler, and he just like shaved a whole bunch of things off. And now, even with the large applications, we're much faster. And I think, it's the same thing with the start time, that every now and then we'll go, ooh, yeah, we haven't looked at this for a little while. And someone will look at it. So like about a year ago, for example, we had, we noticed we'd sort of just that sort of creeping, slowdown that happens to anything that lasts more than a month. And Roberto Cortez did a whole bunch of work on the config. And yeah, some of the optimizations he did, I really love. Like, for example, people tend to namespace if you have an environment variable for config, because config tends to be namespaced. So you'd have, my dot hibernate dot count or whatever. The environment variables will be namespaced as well. So it would be, my underscore project underscore whatever. And so when we're reading the name of the property, we always start at the left, as you do. But of course, the left is the most boring part. The left is the part that's always going to be the same. So he swapped it. So he would just read the string from right to left. So he would, when he's checking for equality, he would get the difference sooner. And, just that little totally sort of non-obvious change gave, this nice speed up. If you had it was fine if you had 3 environment variables, but if you had 200 environment variables, then it would start to make a significant difference.
The craziest and most dangerous hack I ever did with strings was to intern them. But of course, it only works on class loaders, because if you have 2 strings and you call intern, then you can check the equality with equals.
Ooh, yes.
Which is crazy fast. So I was this was an insurance company with lots of XML stuff. So I think after this hack, we were like 100 times faster or whatever. This was like, but you have to know what you are doing, and you have to be really sure that intern was called everywhere, right? So yeah. But the hack from Red is really cool. That if you reverse that, so you can compare strings backwards, and you fail fast, right? So you find earlier if they are different. Pretty cool hack. What is a dev service?
So a dev service is a service that's available at dev time. So the idea is that almost always, if you have an application that's non-trivial, you're going to have a whole bunch of supporting services. So you will probably have a database. You might have something like Kafka. If you have observability, you might have your observability stack. And in general, what we've tended to do as developers is gone down one of two paths. Historically, what we've always done is we've sort of just used like H2, and we've said, well, H2 isn't really the same as my actual database, but it starts fast and it runs in memory and it's close enough, so we'll just do that. Or we've said, here is your Docker Compose script, because in order to run this, you need these 6 things. Because of the magic of containers, it's now remotely feasible to start them, but you still have to do all this setup. And both of those are, well, H2 works really nicely, but it's not actually your service, and it's only for the database case. Yeah. And the sort of the Docker solution, it just adds an extra bit of work of all I want to do is do my Java code, and I have to start this stuff. And so what we do with Quarkus in dev mode is we look at your dependencies and we start the service for you. So for example, if I have a REST application and I've got the Postgres dependency, but I don't actually have my endpoint configured, I don't have the configuration to say my Postgres server lives on port 1234, then when we start up, we'll just start a container for you. So that's something that's provided by the extension, is it will have the code to start a container. Obviously, this only works, well, in general, this only works if you have a container runtime available, because most of these services have a container dependency. But it works really pretty nicely, and it means that when you're running your tests, there's just a whole bunch of infrastructure that you don't need to write for your tests. So it's really nice as sort of for the experience of developing, because it means I can just start coding. And it's also really nice for tests, because it means that if my tests are running in CI/CD, I don't need to write in my POM, before this test start, here's the container that I wish you to start, and use the Fabricate plugin or whatever. It just works. And it means that because I'm not having to fake an alternative for my dependency that's easier to manage, the behavior is much closer to the behavior that it will be in production. And so then that means that my tests are more accurate.
And is it enough to have the Postgres, just a general Postgres dependency, or does it have to be a Postgres extension?
It would have to be the Postgres extension.
So the Postgres extension contributes to a kind of a registry. So the dev services are knowing, there is a Postgres which can be used in a dev service as a dev service, right?
Yeah, the logic, at least some of the logic has to be in the extension itself. So if you're writing the extension and you want to contribute a dev service, you have to call, it's about 10 lines of code or so in order to declare the container and provide the class for the container, and then hook and say, here's my dev service, here's how you start it, here's when you might want to restart it.
You invited me once to the Quarkus Insight and podcast or YouTube channel. And what I did there is what I usually do in projects. So I implemented, I think, 2 modules. One was the Quarkus and the other one was ST. And system tests. And the idea is that the system tests are calling the Quarkus module And I know.
Oh, yeah, I remember that was really cool.
Yeah. And what I'm thinking about is one of the common questions is so this works well in lots of projects, and so we are so different. I call it sometimes system test as an application because I'm misusing Quarkus to test another Quarkus. but but thinking about that, just thinking that my system test module, or maybe even my main Quarkus module could become a dev service itself. Because the problem you have with multiple projects is that in order to test one project, you need the existence of another Quarkus.
Mm-hmm.
So what you could do is actually to create an automatic extension which registers my main Quarkus application as a dev service. Let's say it's called B. So if I'm writing now test service A in Quarkus, I could start my other service automatically and run the system test again.
Yeah, that could work really nicely.
This could work, and I think even would. And the cool story is sometimes I would like to mock the service. So I could say, don't call the real service, just return this JSON, because we know that we have JAX-RS basically everywhere.
Mm.
And we could just prepare the responses and then say, if someone calls that, return this. Because this is a common question, I have one microservice which depends on other microservices. What do you do there? What I try to avoid is mocking, because if you mock out the others, you didn't test anything. No HTTPS and all the problematic stuff is not tested, and I know that it will work. Mm. And by the way, if I just write unit tests, I don't need anything. I would just write the logic and mock out the entire environment. More interesting is I will end-to-end tests for service A would call a service B, and even if the service B doesn't return, the real data, we could slow it down. We can provide some errors. We can simulate errors. This could be actually a cool hack, right?
Mm. And it might be, depending how you did it, it might be as well that you wouldn't even need to write an extension. I'm not sure. But one of the things that we were asked for a really long time, and I think we did it, I think about a year ago, is compose support. So people would say, well, I've got my compose file that has my 4 dependencies, and they kind of need to start in the right order, and they kind of need to connect to each other and that kind of thing. So just having 4 loose dev services might not be quite enough. Can you use the dev service framework to start my compose file? And we would say, sounds like a nice idea. No, but now we can. Mm-hmm. So we have support for compose dev services. So it could be that if you had a compose file, that you could just use that support and do it.
But not even without compose could work, because in this particular case, we don't even need Docker, right?
Yeah.
Because we have everything in place. So. And with the dev service multitenancy, it could be even possible to run the other Quarkus. just thinking loud, because I got the idea right now. But it could be a possibility that you can, if everything is Quarkus in the project and you have 2 microservices which communicate with each other, one microservice in dev mode could start another microservice for testing, for instance, right? This would be easily doable, actually.
Yeah. One of the things I want to do with dev services too, and I don't know whether it actually helps or not, but we sometimes have a problem with dev services because, the dev services are so cool. But if you run in a corporate environment which restricts Docker, which a lot of the ones in the really regulated industries like banks do, then almost all of the dev services are unavailable to you, because most of them rely on Docker. But we're now seeing some really cool things with WASM where you can run, for example, I've just blanked. One of the SQL databases can be run as a WASM
not MySQL, the small one, SQLite.
Yeah, it's like mini SQL or something.
SQLite and Postgres.
Yes, SQLite. Yes, that's the one. Mm-hmm. Yeah, and I'm wondering whether we can extend that to some of the other databases and have sort of like a priority system for dev services. So we would say, like, if Docker is available, then let's definitely use that. But if it's not, and you didn't configure a database, rather than failing, will run it in WASM, and there will be a performance penalty for running it in WASM in most cases. But it means that we can run this really secure sandbox with your actual dependency, and it just works.
You could also provide hooks, right? So I could have a generic dev service, and you can call HTTP or whatever, or execute Java code. Because what I do a lot right now is I use Shebang with Java. So all my scripts are in Java, basically. And if you will call my script, I could do whatever you like, right? I could go with HTTP. I could launch Quarkus, do whatever, right? So it'd be cool to have extension template with predefined hooks, and I can just register whatever I like there.
Yeah, that would be really nice.
Yeah, perfect. Did we cover all the dev services, or is it a lot more?
No, I think that's basically it. The really nice thing about dev services is they're actually really simple, which is that if you do nothing, you will get your dependency started.
Perfect. Where people can find you on the internet?
So I've got a site at hollycummins.com where I blog, not as much as I intend to, but I do blog occasionally, and I share all my talks and that kind of thing. And I'm also on Blue Sky at Holly_Cummins.
Thank you a lot. And if you search Quarkus Dev Services, you will find a lot. So everything is well documented. And it was nice to chat with you.
Yes, thank you very much for hosting me.